Hello. Today we will discuss about hexose monophosphate shunt or HMP shunt. And this is an alternative pathway to glycolysis and TCA cycle for the oxidation of glucose. This is also known as pentose phosphate pathway or phosphogluconate pathway. In this, there are two stages of hexophosphate monophosphate shunt. One is oxidative phase and another is non-oxidative phase. In the oxidative phase, first step is from glucose 6 phosphate there is a formation of 6 phosphogluconolactone in the presence of enzyme glucose 6 phosphate dehydrogenase, and in this reaction one NADP positive is converted to NADPH plus H positive. In the next step 6 phosphogluconolactone is converted into 6 phosphogluconate in the presence of enzyme gluconolactone hydrolase. In the next step 6 phosphogluconate is converted to ribulose 5 phosphate in the presence of enzyme 6 phosphogluconate dehydrogenase, and again in this step one NADP positive is converted into NADPH plus H positive. Now summary of this reaction is from glucose 6 phosphate plus water plus 2 NADP positive combined to form ribulose 5 phosphate, carbon dioxide 2 NADPH plus 2H positive. Since 3 molecules of ribulose 5 phosphate are required in the non-oxidative phase, so the reaction becomes by multiplication 3 molecule of glucose 6 phosphate plus 3 water molecule plus 6 NADP positive molecule combined to form 3 molecules of ribulose 5 phosphate plus 3 carbon dioxide plus 6 NADPH plus 6H positive. Now in the non-oxidative phase 2 molecules of ribulose 5 phosphate epimerizes to form 2 molecules of xylulose 5 phosphate, and 1 molecule of ribulose 5 phosphate isomerizes to form 1 molecule of ribose 5 phosphate. Now xylulose 5 phosphate combines with ribulose 5 phosphate in the presence of enzyme transketolase to form pseudoheptulose 7 phosphate and glyceraldehyde 3 phosphate. Now this pseudoheptulose 7 phosphate with the combination of glyceraldehyde 3 phosphate transadolases to form fructose 6 phosphate and erythrose 4 phosphate, and then in the last step xylulose 5 phosphate plus erythrose 4 phosphate in the presence of enzyme transketolase forms fructose 6 phosphate plus glyceraldehyde 3 phosphate. Now the summary of this non-oxidative phase is 3 molecules of ribulose 5 phosphate forms 2 molecules of fructose 6 phosphate and 1 molecule of glyceraldehyde 3 phosphate. Now sum of total both oxidative and non-oxidative phase include now 3 molecule of glucose 6 phosphate plus 3 water molecule plus 3 NADP positive molecule combined to form 2 molecule of fructose 6 phosphate plus 3 molecule of plus glyceraldehyde 3 phosphate plus NAD 6 molecule of NADPH plus 6 H positive molecule plus 3 water molecule, 3 CO2 molecule. Now significance of HMP pathway. Now first is HMP pathway provides small organic compounds that can be used for synthesis of purines, amino acids and coenzyme. Small organic compounds of 3, 5 and 7 carbon compounds combined to form purines, amino acids and coenzyme. In the second step, next is pentose are required. Pentose are required in the synthesis of nucleic acid such as DNA and RNA and nucleotide coenzyme ATP, NAD positive and NADP positive, and glycoproteins and gums, etc. HMP pathway is the major pathway for the production of NADPH. The NADPH molecule has important role in several biological processes, such as first is NADPH has important role in general metabolism, biosynthesis of fatty acid, cholesterol and glutamic acid. NADPH is involved in the antioxidation reaction to remove the free radicals from the cells. NADPH is also used in the detoxification of xenobiotics, that means foreign elements, The reaction is catalyzed by the cytochrome P450 system. Phagocytosis of foreign material by WBC in blood need the supply of NADPH. NADPH is needed to maintain the integrity of RBC membrane. The lens of the eyes should maintain high concentration of NADPH to preserve its transparency. Thank you.